Let us see what are the conditions for the stationary waveforms and the flicker-free waveforms in a CRO. So before we see the conditions for stationary waveforms and flicker-free waveforms in a CRO, let us see the necessity of a time-based voltage. In order to deflect the electron beam in a CRO horizontally proportional to time, a voltage is needed which rises linearly with time. This is known as the time-based voltage. So it is used to control the position of the light spot on the screen in X direction. It is then necessary to convert the horizontal deflection into a time axis. So a special unit inside the oscilloscope called the sweep generator or time-based generator provides a periodic voltage waveform that varies linearly with time. So this waveform is called as a sawtooth waveform or a ramp waveform. So when an AC voltage is applied, for example, if a sine wave is applied to the vertical deflecting plates and no input is applied to the horizontal plates, the spot on the screen moves up and down continuously, that is, vertically. A ramp waveform applied to the horizontal deflecting plates of an oscilloscope causes the electron beam to be deflected horizontally across the screen from left to right and right to left. So the sine waveform is applied to the vertical deflecting plates is synchronized with the ramp. The waveform of sine wave is displayed on the screen with respect to time. So how to get stationary waveforms in CRO and how to get the flicker-free waveforms in CRO. Let us see this. So what do you understand by stationary? Stationary is nothing but a stable waveform or which does not move. So to get stationary waveforms, starting of the sweep wave should be in step with the input signal. Next, the frequency of input signal should be equal to sweep signal frequency or exact multiple of the frequency of sweep voltage. So conditions for stationary waveforms on CRO is, in order to obtain the stationary waveform on CRO screen, the horizontal sweep frequency and the vertical input frequency signals must be applied to the corresponding deflecting plate at the same time. That is, they are to be synchronized. Synchronization has to be done to obtain a stationary pattern. This requires that the frequency of vertical input signal must be equal to or an exact multiple of the sweep generator frequency. If the vertical input frequency is not exactly equal to or an exact multiple of the sawtooth frequency, the waveform will not be synchronized and the display walks across the screen. That is, the display is not stable, it is not stationary, the waveform moves. So, this is called the display walks across the screen. So, the waveforms on the CRO CRO screen moves left to right or right to left. They are not stationary. The frequency of sweep is not integral multiple of vertical signal frequency. So, when the wave moves left to right, the internal sweep frequency is less than the vertical signal. When waveform moves from right to left, the internal sweep frequency is greater than the vertical signal frequency. In either case, the stationary waveforms are obtained by varying the variable sweep control. This control sets the sweep signal frequency into integer, integer multiples of vertical signal. So, as we discussed, if the condition is not satisfied, that is, the vertical signal should be exactly equal to or multiple of the ramp waveform or the sawtooth waveform, then the pattern rolls or moves along the axis. If frequency is too high, the pattern moves from left to right. If the frequency is too low, the pattern moves from right to left. So, how to obtain the stationary waveforms? So, synchronization. The interlocking of input signal and the sweep signal can be achieved through a trigger circuit. So, this is how we obtain a stationary waveform. So, to brief up, in order to deflect the beam horizontally proportional to time, a voltage is needed which rises linearly with time, which is known as the time-based voltage, which is used to control the position of the light spot on the screen in X direction. It is then necessary to convert the horizontal deflection into a time axis. So a special unit inside the oscilloscope called the sweep generator or the time-based generator provides a periodic voltage waveform that varies linearly with time. This waveform is like a teeth of the saw. It's also known as sawtooth waveform or the ramp waveform. When AC voltage, for example, a sine wave, is applied to the vertical deflecting plates and no input is applied to the horizontal plates, the spot on the screen moves up and down continuously, that is vertical. A ramp waveform applied to the horizontal deflecting plates of an oscilloscope causes the electron beam to be deflected horizontally across the screen, that is left to right and right to left. The sine waveform is applied to the vertical deflecting plates is synchronized with the ramp. The waveform of sine waves is displayed on screen with respect to the time. So, to obtain the stationary waveform, the conditions are the horizontal sweep frequency and the vertical input frequency signals must be applied to the corresponding deflecting plates at the same time. That is, they are to be synchronized. Synchronization has to be done to obtain a stationary pattern. This requires that the frequency of vertical input signal must be equal to or an exact multiple of the sweep generator signal frequency. If the vertical input frequency is not exactly equal to or an exact multiple of the sawtooth frequency, the waveforms will not be synchronized. The display walks across the screen. That is, the pattern is not stationary. The waveforms on the CRO screen moves from left to right or right to left when the frequency of sweep is not integer multiples of vertical signal. When the waveform moves left to right, the internal sweep frequency is less than the vertical signal. When waveform moves right to left, the internal sweep frequency is greater than the vertical signal frequency. In either case, the stationary waveforms are obtained by varying the variable sweep control. This control sets the sweep signal frequency into integer multiples of vertical signal. Next is flicker-free waveforms. What are the conditions to obtain the flicker-free waveforms? A continuous waveform, you know, which is continuous, or a switching waveform, that is, it has two levels on and off. Flicker means sudden disappearance and reappearance, that is, switching of the input waveform. So, how to get a flicker-free waveform? So, during trace period, electron beam deflects to a distance and it comes back to the initial position. So to make ray trace invisible, the screen is blanked at the rate of sweep frequency. So sweep frequency should be greater than 16 Hz because the persistence of vision of human eye is 1/16th of a second. So if sweep frequency is less than this, the continuity of wave is not there. If sweep frequency is 16 Hz, the trace appears to be continuous and smooth. The minimum sweep frequency recommended is 50 Hz. So, the waveform observed in a CRO must be free from flicker. So, in order to get flicker-free waveforms, the sweep frequency generated by the horizontal sweep generator must be greater than the persistence of vision frequency of 16 Hz. So, it is better to have a sweep frequency greater than 25 Hz to get a flicker-free waveform. So, in CROs, flickering is due to measurement of low frequency signals. So the free running mode of sweep generator is not suited with vertical input signal. In case of low frequency sweep generator, flickering does not occur. So we have to use a low frequency sweep generator while measuring the low frequency general signal so that flickering does not occur. So the conditions for flicker free waveforms are we have to use low frequency sweep generators or use CRO in automatic or the external triggering mode. Last one, to connect the signal to vertical input and external trigger to external triggering input so that we get a flicker free waveform. So to sum up, the waveform observed in a CRO must be free from flickers. So in order to get flicker-free waveform, the sweep frequency generated by the horizontal sweep generator must be greater than the persistence of vision of frequency of 16 Hz. So it is better to have a sweep frequency greater than 25 Hz to get a flicker-free waveform. So in CROs, flickering is due to measurement of low frequency signals. So the free running mode of sweep generator is not suited with vertical input signal. In case of low frequency sweep generator, flickering does not occur. So the conditions for flicker free waveforms are use of low frequency sweep generator, use CRO in automatic mode or external triggering mode, connect the signal to vertical input and external trigger to external triggering input so that we obtain a flicker-free waveform. The minimum sweep frequency recommended is 50 Hz. So, how to get the stationary waveforms and flicker-free waveforms in a CRO is understood. Now, Let us see what are the front panel controls of a CRO. So on the CRO we have number of controls. So before operating the CRO we should know what the purpose of each control on the front panel. So we have an intensity control, focus control, we have the input channels, we have the horizontal control, the trigger control, the vertical control, we have the time measurements, voltage measurements. So this is what a CRO is. The front panel, you have volts per division control, time per division control, you have AC DC ground switch, you have the two BNC connectors to connect the channel 1 and channel 2, you have the screen, the intensity, the focus control, the triggering signals. So here to start with we have a switch to switch on the power, that is a power on switch. It is used to switch on and off the CRO. Next we have the horizontal amplifier input. This is used for connecting the signal as an input for horizontal amplifier, that is the signal to be measured. The vertical amplifier, I'm sorry, the vertical amplifier input, the signal which has to be measured or the signal under test is connected to the vertical amplifier input. Here you can see the intensity and focus controls. This controls, the intensity controls the brightness of the screen. When adjusted, it changes the negative voltage on the control grid of the CRT and the brightness changes. This happens due to change in number of electrons of the beam passing through the grid. Next is the focus control. This controls the sharpness of lighted spot or sharpness of the wave displayed on the screen. Next is the time per division control. This controls the frequency of the sawtooth wave. When adjusted, it changes the number of cycles of a wave displayed on the screen. Next is the volts per division. This controls the amplification or attenuation factor of the vertical amplifier. When adjusted, it changes height of wave on the screen. Thus, very high voltage waveform can be made small according to the size of the screen. Next is the horizontal position control. By adjusting this knob, we can move complete waveform along x-axis from left to right or right to left. This sometimes required for adjusting the position of wave on the xy axis. Vertical position. By adjusting this knob, we can move complete waveform along y-axis upward and downward. Sometimes required for adjusting the position of the wave on the xy axis. X input. This is not a control knob, but it is another input of CRO. When this switch is in external, the internal sawtooth is cut off and some external signal can be connected to the horizontal plates of CRT. Next is Y input. This is main input of CRO. The signal observed on the screen is applied to this input. Astigmatism. This control is generally fitted on the backside of CRO. It is used to correct the tilting of the waveform on the screen. This happens due to aging of CRO. This controls voltages on both deflection plates, rotates the waveform to align it exactly along XY axis. It sees that the total screen is of uniform brightness. So this is the input channel. You can connect. This is a dual phase CRO, so you can connect two signals at a time. One signal to channel 1 and one signal to channel 2. The BNC connectors are connected on the front panel. These are the controls, horizontal controls to adjust the sweep frequency slightly. So the main horizontal control is called the time base. It adjusts the time per division of the display. The position control moves displayed waveforms horizontally. These are the vertical controls. The main control adjusts the volts per division of the display. The position control moves displayed waveforms vertically. The input signal can be DC or AC coupled. So you have the control AC, DC and ground. First you put the switch in ground position and adjust the trace rod on the screen to be in the center of the display screen. When you are measuring AC signals, put the switch in AC. If you want to measure the DC signals, put the switch in DC. Next, the trigger controls. The trigger level control adjusts the displayed waveforms until it becomes stationary. We have seen the need of stationary waveforms or the conditions for stationary waveforms. So this trigger level control can be adjusted so that the stationary waveforms are stationary. The coupling switch is normally kept in auto mode. The source switch is moved to the input channel being used. So the measurements which we can make using a CRO is the time measurement, that is the frequency measurement and the amplitude measurement. So before seeing the different types of measurements which can be made using a CRO, let us just brush up the various controls on the front panel of the CRO. So the power on switch, it is used to switch on and off the CRO. The horizontal amplifier input, this is used for connecting the external horizontal signal as an input for horizontal amplifier. Next, the vertical amplifier input, the signal under testing is connected to vertical amplifier input. Intensity. This is a brightness control. It controls the brightness of the screen. When adjusted, it changes the negative voltage on the control grid and the brightness changes. This happens due to change in number of electrons of the beam. Next is the focus. It shows how sharp the waveform can be displayed. That is a single thin and sharp line. So this controls the sharpness of lighted spot or sharpness of wave displayed on the screen. Next is the time per division control. This adjusts the frequency of the sawtooth waveform, which is generated internally. When adjusted, it changes the number of cycles of the wave displayed on the screen. So here, to get a stationary waveform, the time per division control also can be adjusted so that the signal to be measured, which is connected to CRO, and the frequency of the time-based signal must be multiples of each other. Next, volts per division control. This controls the amplification or attenuation factor of vertical amplifier or attenuator. When adjusted, it changes the height of wave on the screen. So small signals or large signals can be easily and comfortably measured by using the CRO, putting the volts per division position in different positions so that it is comfortable for us to take the readings. It must be not too small, not too large. Horizontal position control. By adjusting this knob, we can move complete waveform along x-axis from left to right or right to left. This sometimes required for adjusting the position of wave on XY axis. So vertical position control, by adjusting the knob, we can move the complete waveform along y-axis, upward and downward. This sometimes required for adjusting the position of the wave on XY axis. X input. This is not a control knob, but it is another input of CRO. When this switch is in external, the internal sawtooth is cut off and some external signal can be applied to the horizontal plates of CRT through X input. So this will be used for obtaining the Lissajous figures on the CRO screen to find out the frequency of the unknown signal connected to the CRO. Y input. This is main input of CRO. The signal observed on the screen is applied to this input. Astigmatism control. When you vary this control, it sees that the screen is uniformly illuminated. One more control we have, trace rod. When the CRO is kept in ground position, the trace or the line on the CRO screen must be horizontal. It should not be tilted. So if it is in a tilted position, you adjust this trace rod switch or trace rod control so that the line is horizontal, not in a tilted position. So these are the different controls of a CRO. We can use a CRO for measurement of current, for measurement of voltage, for measurement of power, frequency, to measure the phase of the sine wave, to measure the time period, to measure the depth of modulation. You can find out the pulse parameters. We can find out or measure the radio frequency, intermediate frequency, audio frequency signals. You can see a composite synchronized TV signal. We can also observe the antenna radiation pattern. So we can use CRO for different purposes, for the voltage measurement, for time measurement, and for different purposes we can use a CRO. So today we have seen how to obtain or what are the conditions to obtain the stationary waves, what are the conditions for flicker-free waveforms, what are the different controls on the front panel of the CRO. So the stationary waves are obtained when the signal to be measured and the sweep are equal or multiples of each other. So you have to adjust the time per division control so that the input signal and the ramp waveform or the sawtooth waveform both are synchronized so that we obtain a stable waveform. Flicker-free waveforms can be obtained so that the persistence of vision is 1/16th of a second. So when you are measuring the low frequency signals, you observe the flicker. So what we do is, for a sweep generator, we have to connect an external sweep generator of low frequency so that you can observe flicker-free waveforms when measuring the low frequency signals. Coming to the front panel controls of a CRO. We have an on-off switch. We have the two channel BNC connectors to connect the two signals. We have AC DC ground switch. We have volts per division control to adjust the amplitude of the waveform to be observed comfortably. We have time per division control to observe the waveform comfortably so that the frequency of the signal is easily visible. Next, you have the internal, external, and auto triggering control. We have the intensity and focus control. We have the astigmatism control. We have the trace rod control. So these are all the different controls on the front panel. So before making the measurements on a CRO, before we use the CRO for various purposes like measurement of the amplitude of a signal, frequency of a signal, time, the I mean the wavelength of a signal, or to find out the pulse parameters, or to measure the depth of modulation of a modulated waveform, we have to know all the functions of the front panel controls of the CRO. Then only we can use the CRO comfortably to make the various measurements. Thank you.